Hi guys, today we're going to solve another problem in the application of differential equations in chemical solutions. So this is still a part of our set B for the board exam refresher for general engineering involving differential equations. Okay, so this will be the last problem that we will be solving for the application of differential equation in chemical solution. Alright, so let me first read our problem. We have a tank that contains 2,000 liters of brine. Brine containing 5 newtons per liter of salt flows in at 10 liters per minute, and the mixture, kept uniform by stirring, flows out at the rate of 20 liters per minute. If the concentration of salt is 8 newton per liter at the end of 1 hour, how much was the concentration of salt at the beginning? And here are our choices for this problem. So first, let us illustrate yung ating problem para mas madali natin siyang ma-visualize. So initially, we have a tank that contains 2,000 liters of brine. Okay, so we know that initially, we have a volume. So let's say this is our initial volume, which is 2,000 liters. Now, a brine containing 5 newtons per liter of salt flows in at 10 liters per minute. So, may pumapasok na brine dito sa ating tank. Okay? And we are told that the concentration of this brine is 5 newtons per liter of salt. And then, it flows in with a volumetric flow rate of 10 liters per minute. And our brine here inside our tank is kept uniform by stirring. So it means that kung ano man yung concentration ng ating brine dito sa ating tank will be the same concentration ng lumalabas dito sa ating tank. And we are told that it flows out at the rate of 20 liters per minute. Okay? So meron tayong lumalabas na solution dito. So this will be our volume 2, which is 20 liters per minute. Okay, so this is a volumetric flow rate. Now, another information given to us is that if the concentration of salt is 8 newton per liter at the end of 1 hour, so our concentration 2 will be 8 newton per liter at the time is equal to 1 hour. Okay, but all of our rate here is in minutes. So, we know that this is equal to 60 minutes. Mas maganda nang gamitin natin yan, ano? Now, the question is, how much was the concentration of salt at the beginning? So, ang hindi natin alam, yung initial concentration ng ating salt dito sa ating tank. Remember na ang given sa atin is a brine, no? Dito sa ating tank. 2,000 liters of brine. So, that means this is already containing salts, no? So, yan ang tinatanong sa atin. Ano yung concentration ng salt at the beginning of the process? Alright, so, we know that at time is equal to 0, our volume is equal to 2,000 liters. But we do not know our CO. Yan yung ating required. So, let us let Q as the amount of salt in the tank which is changing with times. Okay, so this is amount of salt at the tank. Okay, and this is changing with time. Okay. Okay, because may pumapasok at lumalabas sa ating solution. So therefore, nagbabago yung amount ng salt natin dito sa tank with time, di ba? Okay, so let us find out what is the volume at the tank changing at time, no? So volume of the tank which is changing with time. Okay, so alamin natin yan, yung volume ng ating solution sa tank which is changing with time. So initially, we have 2,000 liters, diba? So we have 2,000 liters. And then we have 10 liters per minute na pumapasok sa tank. So we need to add that. So we have 10 liters per minute. So to get the volume, you need to multiply this to time. And then may lumalabas na 20 liters per minute. So we need to subtract that. So minus 20 liters per minute. To get the volume, you need to multiply that to time. So therefore, our volume is equal to 2000 minus 10T. Okay, so this is our volume with respect to time. Now, we also know that our concentration is changing with time, di ba? So, our concentration is changing with time. Okay, so alam naman natin yung ating equation for the concentration. So the concentration is the amount of salt. Remember that we let our Q to be the amount of salt at the tank. So this will be the salt over the volume, right? And since we know that our volume is 2000 minus 10T, we can just substitute that. Our C is equal to Q over 2000 minus 10T. No? Sinubstitute lang natin yung volume. Alright, so now again, to get the basis of our differential equation. Okay, the basis of our differential equation is that the rate of the inflow, so we have the change of the salt over given time is equal to the rate of inflow salt minus the rate of outflow salt. Okay, so yan yung changes na sa salt natin na nangyayari sa ating tank. Okay, so we could get this as dq over dt is equal to ano yung rate of inflow ng ating salt. So this will be concentration multiplied to the volume, no? As you can see, so I will write the units para mas makita ninyo. Then buburahin ko na lang kasi mas makakadagdag pa to sa mga nakikita ninyo during our calculation. Ano? So I said this is volume multiplied to concentration. So we have here 5 newtons per liter multiplied to 10 liters per minute. Okay, so we have 5 newtons per liter multiplied to 10 liters per minute. So as you can see, makakancel yung ating liters. So we will have the amount of salt per minute. No? So that is why I said to get the salt per unit time, you just multiply the volume to the concentration. So we have 5 times 10 here. Hindi na natin isusulat yung ating unit. So we have 5 times 10 minus the rate of outflow, which is, we have the rate. It's coming out at 20 liters per minute. Pero etong given sa atin na C2, this is the concentration at given time T. And we know that this is changing through time. So this is still a variable at this moment. So we have 20 times the concentration. Okay, so we have 20 times the concentration C. Okay, so therefore we have here dq over dt is equal to 5 times 10, which is 50 minus 20c. Kaya lang, nakuha na natin yung equation ng ating c dito, di ba? Our c is equal to q over 2000 minus 10t. So we'll just substitute that here. So we have dq over dt is equal to 50 minus 20 multiplied to q over 2000 minus 10t. Okay? Now, let us rearrange this to get the linear differential equation. Now, I'm going to transpose this term papunta sa left side ng ating equation. So, we have dq over dt plus 20 over 2000 minus 10t times q is equal to 50. Okay, so binagbaliktad ko lang itong 20 and q natin, no, para mas maging obvious that we have a linear equation dito sa ating calculation right now. But let me simplify this further, no, because we know that our numerator here and our denominators are both divisible by 10. So let me divide this by 10, ano, para mas simplified yung ating equation. So we have dq over dt plus 20 divided by 10. So we will have 2. So we have 2q over 2000 divided by 10. So we have 200 minus 20 divided by 10. So we have t. Okay. Then we have is equal to 50. All right. So now we have a linear differential equation of the first order in here. So we know that our P here is equal to 2 over 200 minus T, and our Q for the differential equation is 50. Ito yung nasa right side ng ating equation. So kung medyo nalilito kayo kasi ngayon nyo palang napanood yung video natin, you can watch the first part up to part 3 ng ating series for sets B ng ating reviewer for general engineering, no? Kasi mas in-explain natin to doon in details. So dito, sinusolve na lang natin siya directly. Okay, so now we're going to solve for our integrating factor. And we know that our integrating factor is equal to e to the integral of p dt. Okay, so substitute natin yung p. We have our p here. So we have e, the integral of our p, which is 2 over 200 minus t dt. Okay, so ilalabas lang natin yung ating 2e to the 2, the integral of dt over 200 minus t. Alright, so we have this as e to the negative 2 ln of 200 minus t. Okay, so integral calculus lang yan at makukuha na natin agad just by getting the derivative of our denominator. Ano? So kaya nagkaroon tayo ng ln 200 minus t. But of course, we know that we can simplify this further. Okay, so we will have here e to the ln of 200 minus t raised to negative 2. And so therefore, our integrating factor is equal to 200 minus t to the negative 2 by applying our rules of logarithm. Okay, so apply na natin ngayon yung natutunan natin in solving the differential equation ng linear equations of the first order. So to get that, we have our integrating factor, which is 200 minus t to the negative 2 multiplied to our q. Okay, because in this equation, we will just be multiplying our integrating factor by q in here. Okay, so we have q. And this will be equal to the integral of our integrating factor, which is 200 minus t to the negative 2 times our q, which is yung nasa right side ng ating equation, which is 50. And then we have dt in here. Okay, so now we're going to solve this. So we're going to take out our 50. And then we'll get the integral of 200 minus t dt. So we'll get the derivative of 200 minus t. So this will be negative dt. So therefore, we will have negative sign in our answer. So we have negative, or better if I'm just going to take it out dahil meron naman tayo ditong constant na 50. So I'll have negative 50 here. And then we have 200 minus t. And then our exponent will be negative 2 plus 1. So we'll have negative 1 here. And we will also have a denominator of negative 1. Okay, so since this is indefinite integral calculus, so we're going to have plus a constant here. We're going to use plus k. Normally in integral calculus, we're using plus c. But in order not to get confused sa ating c, which is concentration, I'm going to use k. Okay, so therefore, we will have here, I'm going to write this again. So we have 200 minus t to the negative 2q is equal to negative 50 divided by negative 1. So we have positive 50. And then 200 minus t to the negative 1 plus k. Alright, so I want to isolate yung q sa left side ng ating equation. So we're going to transpose this sa right side ng equation. So we have q is equal to 50. Then 200 minus t to the negative 1 divided by 200 minus t to the negative 2. So that means we will have positive 1 no, sa ating exponent. So therefore, we will have 200 minus t, positive 1 yung ating exponent, plus k divided by 200 minus t to the negative 2. So since this is an inverse, we will have this in our numerator as 200 minus t squared. Okay? Alright, so we have an equation now, pero hindi pa rin natin alam kung ano yung value ng k, and we don't know the value of q and t. They are variables. We know that k is constant, kaya lang hindi pa natin alam yung value niya, no? And unlike sa mga previous problems na sinolve natin, nakuha natin yung k by taking the value of q and t at time is equal to 0, di ba? Because we know the value of q at time is equal to 0. But this time, hindi natin alam kung ano yung value ng q at time is equal to 0. Alright, so hindi natin pwedeng gamitin yung procedure na ginamit natin in problem number 8 and problem number 9. Because we are looking for the initial concentration of the brine. Okay, so let's don't forget that. So we are looking for initial concentration of the brine in the tank. Yan yung hinahanap kasi natin. Okay, so how are we going to do that? So alam natin that our concentration is equal to Q over, kanina yung sinolve na natin yan eh. This one here. Q over 2000 minus 10T. Okay, so let us use that. So we have here Q over 2000 minus 10T. But again, this is divisible by 10. So let us simplify that. We have Q over 10 times 200 minus T. Okay, so pinactor lang natin yung 10. We just factor it out. And then we know our Q, no? We have our equation of Q right here. I'm going to substitute that. So we have C is equal to, so let's substitute yung ating Q. Okay, itong nasa itaas. So we have 50 times 200 minus T plus K over 200 minus T squared. Okay, and then our denominator is 10 times 200 minus T. So as you can see, we have 200 minus T both sa numerator and denominator. So we can just divide these terms ng numerator sa 200 minus T. So we will have C is equal to 50 divided by 10, which is 5. Then 200 minus T divided by 200 minus T. So it will just be cancelled out. And then we have plus K over 10 times 200 minus T divided by 200 minus T. So we have squared in our numerator. So this will be 200 minus T. Okay? So let me move na lang itong ating 10. Okay, para mas maging malinaw yung ating equation. Okay, so tanda natin, we have this given at the end of our question. We are told that the concentration of the salt is 8 newtons per liter at the end of 1 hour. So that means at time is equal to 60 minutes, our C2 is equal to 8 newtons per liter. So that's what it means, no? So we're going to use that. Okay, so at time is equal to 0. So at time is equal to 60 minutes. So we have at time is equal to 60 minutes. Our concentration is equal to 8 newtons per liter. Okay, so we're going to use that. Okay, so concentration is equal to 8. Then this is equal to 5 plus K times 200 minus T. Our time is equal to 60 minutes divided by 10. So we're going to solve for K. So 8 minus 5 will be 3 times 10. So we have 30. No? So we have 30 is equal to K 200 minus 60. So let us subtract that. So we have 200 minus 60 is equal to 140. Okay, so therefore our K is equal to 30 divided by 140, no? So let us just use this 30 divided by 140. So we have 0.214. So 0.214. Alright, so ang pinapahanap sa atin is yung concentration C at time is equal to 0, di ba? So we need to find at time is equal to 0, what is the concentration? Okay, so again, alam na natin yung value ng K. So we will just use this equation, pero alam na natin ngayon yung K. So we have C is equal to 5 plus our K, which is 0.214. Okay, times our 200 minus time over 10, di ba? So we have time is equal to 0, so we need to find C. So we have C is equal to 5 plus 0.214 times 200 minus T, which is 0. So we have 200 here divided by 10. Okay, so our C is equal to 5 plus, so let's use our calculator again, 0.214 times 200 divided by 10. Okay, then plus 5. So alisin na natin tong 5 dyan. So plus 5. We have 9.285. So we have 9.29. Okay, so we have 9.29 here. So let me remove this. Alright, so 9.29. So ang unit natin is Newton per liter. So this will be our final answer here sa ating final question. So 9.29. So tignan natin sa ating mga choices. So we have letter B, which is 9.29 newtons per liter. Alright, so natapos na natin yung ating set B. So I hope mas natutunan na ninyo or na-master na natin, no, itong application of differential equations in chemical solutions. So that's all for now, guys. Thank you very much and have a nice day.